Duper. Okay, so here we are in Logic again, using my favorite toy, the signal generator, as usual. And let's just use one at a time. We've got a 300 hertz tone. Let's bring that up so that it's more annoying. Yeah, that's a nice annoying frequency. Okay, so we have 1 kilohertz tone now, and it's just playing away. And we're going to turn on another. The amplitude changed. The reason is because we're adding 2 frequencies together. They're 2 of the same frequency together. I don't know what their phases are. There's some destructive interference. If we change this, you hear the pulsing as we did before. The difference is this time we're not multiplying 2 signals, we're just adding them together. So this is kind of a demonstration of how one of those things is very similar to the other, equivalent in some senses. So the beat frequency is happening at 1 hertz. If you were to count the times between the loud peaks, you'd find they're 1 second apart. If you increase this, now it's beating at 10 hertz. So that's pretty straightforward. These signals are just getting added together. Nothing fancy is happening here. If you want to take a look at what's actually happening with these signals, we can go over to Mathland, where let's do 1K, just as we were doing before. We have 2 signals that are added together, sine of F1 and sine of F2. And if you zoom out far enough on one axis and not the other, you will see that indeed when they add up, you get this speeding here. And the reason is, for part of this cycle, the signals are reinforcing each other. So that gives us a maximum amplitude of 2, which shouldn't be surprising. If both sine of F1 of x and sine of F2 are x at a maximum, you're going to get an amplitude of 2. But when they're completely out of phase, you see this little thing right here where they destructively cancel out. And sure enough, if you change these frequencies, you're going to get those effects. Now, it's not quite as obvious here because now the beats are happening at, 904 hertz is one of the beat frequencies, and the other is happening at 1104. So it's not always obvious. This is the case where you would have 2 tones being multiplied by each other, where one of them, they're both in the hundreds or thousands. So it's not very visually clear, but it's a nice example that when you bring the frequencies very close to each other, you actually see the swelling in amplitude. Okay. I think that's all I have to say on the subject. Questions?